Can you hear me okay, Lauren? Hi, Lauren. Can you hear me okay? Can you hear me okay, Lauren?
Yeah, hi.
How are you?
I'm good, how are you?
Good. All right. Let's see. Trying to clean up your, I know this is your first time, but normally you put one on each page
Mm.
so that I can write on them. But that's okay. I've cleaned it up. All right. So have you already done a lot of these, or are these the ones you just don't know how to do?
These are the ones I just don't know how to do.
Okay. All right. So we're just so you know, I'm recording this on I'm streaming this on um on YouTube live through Zoom.
Mm-hmm.
So you can watch this when we're done. If you go to my website, go to my YouTube channel, you can see
Okay.
the video. It'll be there later. So because I'm going to go through relatively quickly through a lot of these things, and just stop me when you're if you're confused by something. So this
Okay.
first one here, I'm on page 17. Can you see my screen okay?
Yeah.
All right. So it says list the sequence of transformations, then sketch a graph of the function. Now this is your final. You probably aren't going to have to do it obviously like this. I'm thinking it says plot at least 3 points. So the transformation. So I'm going to go ahead and write this out here. Let's see. Second, I'm getting situated so I can write better on my Jamboard. Okay. So the first thing that you're going to see is, I'll write this to the right over here. The base graph is, of course, x squared, right?
Mm-hmm.
So it's just, which is just a parabola, right? So your parabola, your base graph would look something like this. It would just be here, 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 and it would be like that, and it would be like that. So that's your y equals x squared graph.
Mm-hmm.
But this graph is going to do, there's 3 things that are happening to it. First of all, the -2 flips it, since it's a negative on the outside with the y, it flips it upside down,
Mm-hmm.
right? So in other words, it flips it over the x-axis. Okay.
Mm-hmm.
And then it also stretches it vertically. Okay, so that 2, what that 2 and that -2 is going to do, if it was just that, it would take this point, for instance, right here, 1, 1, and it would make it, instead of 1, -1, it would make it 1, -2. So it stretched it. It
Mm-hmm.
flipped it upside down, but it also stretched it. So it's narrower. It goes up quicker, or in this case, down quicker. You follow that?
Yeah.
So that's one thing that's going to happen. This is also, what's that going to do to it when you subtract 1 from the x? Do you remember?
No.
So when you're dealing with things on the inside with the x, that moves it right or left. So in this case, it moves it right 1. Okay. And what
Mm-hmm.
is this going to do to it?
Up or down?
Right. And it's going to be up 3. So your graph is going to look like this. I'm going to make it white. Your graph is going to go, so your point, which was here, your point 0, 0, is now going to be right 1 and up 3. So that's my point. Oops. Right 1, up 3, that's my new vertex. Can you see that okay?
Yeah.
The white on there. And then, so that's the vertex, but then it's gonna go, instead of going over 1, up 1, like it would normally do, right? Over 2, up 4, it's gonna go over 1, down, instead of 1, because it's a -2, it's gonna go over 1, down 2. So that'll be one of your points. Over 1, down 2, and it's symmetric, so there's gonna be a point there as well, to the left 1, down 2. And then instead of going to the right 2 and down 4, it's gonna multiply that by 2. So it's gonna be down 8. So it'll be right 2, down 8. So this started at 3, so it's gonna be at 5, or -5 rather. So your point's gonna be right, let's see, where's 5? Right there. And then remember, we've got an axis of symmetry here that goes through the vertex. I'll draw it in there just to help you understand what I'm doing. So there's your axis of symmetry. So then the point over here is going to be there as well. So that's what your graph is going to look like.
Okay.
And now you can check it. Did you follow what I did there? Do you understand how I did all that?
The only thing I don't get is the down 8. Why?
So the reason you're doing that is because the quadrant, look at my red again. Look at my original graph. Your normal quadratic, x squared, if you go over 1, what's 1 squared?
It's 1.
It's 1. So if you go over 1, you go up 1.
Mm-hmm.
If you go over 2, what's 2 squared?
4.
4. You go up 4. That's how you get those points, and it happens on the left and on the right. But with the white one, I'm actually multiplying that by a -2 on the outside. So if you have a -2 on the outside, what you're doing is, after you go over 1, instead of going up 1, you're going up 1 times -2. So you're going, actually, instead of going over 1, so here's my vertex, right? The white graph. Instead of going over 1, up 1, I'm going over 1, up, or down 2, because the -2, that's what the -2 did. And normally I would go over 2, up 4, but I'm multiplying that by -2. So -2 times 4 is -8. So I will go over 2, down 8.
Oh, okay.
Okay. And you can actually check those points. They said plot at least 3 points. Well, we plotted 5 points, but you can check them and just just to make sure you did it right, plug in this. That point should be 1, comma. Do this in white. That point should be 1, 1. Or 1, 2. Sorry, 1, 2. So check if you get 1, 2. If you plug in, or is it 1, 1? No, it's 2, 1. My bad. I'm going over 2, right?
Yeah.
So that point is 2, 1. We should get 2, 1. Plug in 2 and see if you're going to get 1 here. When you plug in 2, you get 1 squared, which is 1 times a -2 plus 3. And you sure do, you get 1. So 2, 1 is a point.
Oh.
You got it?
Yeah.
And if you plug in 0, notice if you plug in 0, you're going to get the same point, because you still get -1, but that's squared. So you also get 0, 1.
Oh.
Okay, makes sense?
Yep.
All right, the next question, you said graph the piecewise function. So when you have a piecewise function, and then it wants you to evaluate these different things, we're going to look at different pieces. So this piece I'm going to make white, okay? And the second piece I'll make yellow, or maybe not yellow. Yellow is kind of hard to see. Green. Let's try green. Can you see that okay? Okay, so can you tell what kind of graph this first piece is?
Linear. Wait.
Yeah, that's right.
Yeah.
It's a linear. It's a line, and what's the slope of it?
-2.
Good. So your slope is -2/1, right? Let's write it like that. Got it?
Yeah.
Now your y-intercept is what?
1.
Can you see? Yeah, your y-intercept is 1. Very good. So if I were just trying to graph that line, that white line, what I would do is I would start with 1. You remember doing this before? And I would go down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1, or up 2 and to the left 1, right? Up 2, left 1, up 2, left 1, up 2, left 1. Do you remember that? That's the way that you would graph that line before. The problem with this is that this isn't actually, the line isn't defined for all x values. It's only defined when x is less than -1. Okay, so instead of doing it like that, what you should do is, so I'm just going to erase that whole thing. What you should do is you should start at -1. You should plug in -1 into the function. So I'm plugging it in. I'm finding f of -1 and find out what you get. Notice what I get is 2 plus 1, which is what?
3.
3. Good. So my point is going to be -1 comma 3. But because there's no equal to sign underneath that less than symbol, I'm going to put a open circle there. So -1 comma 3, that's where I'm going to start. Instead of starting at my y-intercept, I'm starting at that point. And now instead of going to the right, down 2, right 1, down 2, right 1, it doesn't go to the right, it only goes to the left. This function is only defined when x is less than -1. So instead of going down 2 and right 1, I'm going to go up 2 and left 1 to get those points that are to the left. Make sense?
Yeah.
So there's a point, there's a point, there's a point, and then etc. So now I'm going to draw my line in there. Okay, there's that piece. There's the first piece of my function. Okay. All right, now we're going to do the same thing for the green piece. What's the slope of the green piece?
1.
Good, so it's 1/1, right? And where should I start this green piece? Should I start it at the y-intercept?
I don't know.
You should start it
At
at that x value.
Yeah.
Right? So plug it in. Plug it in. -1 plus 2 is what?
1.
1. So your point, the point is going to be -1 comma 1. And am I gonna fill that point in?
Oh yeah.
That's right. So -1 comma 1 is right here. I'll make it a solid dot. And then what's the slope?
1.
So should I go right or left or both directions?
Right.
Yeah, I only go right because that's how it's defined.
Yeah.
You see how it's defined for x is greater than -1. So that means everything this direction is where I'm plugging that in. So I do it 1 over 1 up 1, over 1 up 1, etc. And there's my graph. So the piecewise function, basically you're just, what that just means is you're defining the function on different regions of the graph. I defined it from here to the left with the white function, right? And I've defined it from here to the right with the green function. So you just have to make sure that you start your function at the right point, and then you draw your function in. So the next one says evaluate the following. Well, to find the values of them, you could just look at the graph, right? So what is f of -3? We'll go to -3. Here's -3 and go up or down till you get to the graph. There it is right there.
Mhm.
And because I drew it in carefully, I could actually see what that is. I can just count it off at 7. Or if you would rather, you can just literally plug it in. Just make sure you plug it into the right piece, which in this case would be the white one, because it's less than -1. Follow?
Yeah.
Oops, I put a -1. -3. -2 times -3 is +6. 6 plus 1 is
7.
7. How about this next one? Where is -1 defined? Which one? White or green? Which one should I plug that into?
Green.
Yeah, the green one, because it says equal to, right? And we already found that, didn't we?
Yeah.
It was 1. And how about 2? White or green?
White. Wait, green, sorry.
Yep, green. And so can you do that in your head?
4.
Good. Again, or you could just look at the graph and you can go over and say 2 over, 4 up, done. Okay, so that's piecewise functions. Good. Questions about that or no?
No, I'm good.
All right, the next one says graph the solution set of the system.
Mhm.
So now see, this is different because this is inequalities. You see how these are inequalities?
Mhm.
All right. And can you also see that these inequalities are not in slope intercept form?
Yeah.
All right, so let me, your teachers, sometimes teachers don't explain this or teach this, but I prefer to teach this way.
Mhm.
If your equation, if your inequality is in standard form like this,
Mhm.
don't use the slope intercept form method for graphing it. Use the intercept form of graphing it. And what I mean by that is you really want 2 points. All you really need to graph a line is 2 points, right?
Mhm.
If it's a linear equation. See how these are both linear?
Mhm.
So the 2 points that you should use to graph it are the intercepts, meaning you should find one of your points where you plug 0 in for x, that's your y-intercept, and the other point where you plug 0 in for y, that's your x-intercept.
Mhm.
And watch how easy it is to do that. If I plug 0 in for x to this first equation, this white equation, inequality, sorry. If I plug 0 in for x, what that means is this is just going to be gone. So I'm going to cover this up. And while I cover it up, in your head, you solve this equation. -y equals 1. Okay? Go
Mhm.
ahead. -y equals 1. What does y equal?
Wait, what?
I want you to solve this equation. I'm plugging 0 in for x, and we're going to find out what y has to be. Plugging 0 in for x, because I'm finding the y-intercept,
Mhm.
right? So I'm plugging 0 in, and plugging 0 in means basically this is just gone, right?
Mhm.
See how I'm covering that up? And
Yeah.
I'm asking you to solve that equation while I cover it up.
1.
-1.
Negative. Yeah. -1.
Got it?
Yeah.
Let's do
Oh,
the
yeah.
let's do the other one. Now I'm going to plug in 0 for y and to find the x-intercept. Okay, you ready? I'm
Mhm.
plugging 0 in for y, so this is gone, right?
Mhm.
So what does x equal?
-1.
Not -1.
Why would it be +1?
In that case, it's going to be x minus 0 equals 1.
Huh?
So what is, if I plug 0 in for y, does this negative matter anymore?
No.
No. So what is x equal?
Oh, 0.
Not 0. What does x equal?
X minus 0.
Look at this equation to the right.
Yeah.
What does x equal? Solve that. What's x minus 0?
X
So x equals what?
1.
1. Got it?
Wait. Oh, okay. Yeah. Okay, I got it.
Okay. So I'll do it. We'll do it again for the next one. The more you do it, the easier it gets. So 0, -1 is here. There's your y-intercept. 1, 0 is here. There's your x-intercept. And that's all you need. 2 points. and you can graph the line, and your line goes like this, roughly. Doesn't have to be perfect, right? Now we have to shade it one way or the other. Which way am I going to shade it? Do I shade it above or do I shade it below the line? Can you tell by just looking at the sign?
Would it be everything below 1?
No, you can't tell by looking at the sign because it's not in slope intercept form. Y isn't by itself, so you can't tell that. So in this case, what you have to do is you have to use a test point. So find a point on one side of the line or the other. Just find any point. I'm going to choose this point right here, 0, 0. Do you see it?
Mm-hmm.
See how 0, 0, 0 is on the left side of the line? You see that?
Yeah.
So I'm going to test this to see if that's a solution. And if it is a solution, that means everything on this side is a solution. If it's not a solution, that means everything on the other side is a solution. Got it? So let's test it. Ready? Plug in 0, 0. Is 0 minus 0 less than 1? Is that true?
Yeah.
It is true. So that means that everything on this side is a solution. So I'm going to shade everything above it. Got it? Okay. So we've done that one. Now let's try the other one. Again, I'll do this in, actually, I'll do this in black. Okay. Now we're going to do this equation. I'm going to do it the same way I did the other one. Okay. You ready? Let's see if you follow what I'm doing. I'm going to plug in 0. Remember, I want to find 2 points. I'm going to find this is the Y-intercept by plugging 0 for X. And I'm going to find the X-intercept by plugging 0 in for Y and solving for X. And I'm going to do it by just in my head, watch what I'm doing. When I plug 0 in here, what happens to the 2? It's gone. So watch, can you solve that equation while I'm what I'm doing is I'm covering this up. I'm just showing you how I'm think about it. Just ignore this and solve that equation. Solve this equation. 3y equals 12.
4.
4. You see how easy that was?
Yeah.
Okay. Do the same thing for the other one. Now I'm plugging 0 in for what?
A Y.
And that's gone. So what's X equal?
6.
There you go. See how you do it? See what I'm talking about? That's how I like to do those problems. So 0, 4 is up here. 6, 0 is over here. I draw the line. Oh, by the way, I forgot with that white line. I should have also done what with it? Is it a solid or a dotted line?
Dotted.
Yeah, I should have made it a dotted line, right? So I'll go ahead and take my eraser and erase some of that because that's a dotted line. Okay. The black line, is it solid or dotted?
Solid.
Good. And which way do I shade it? Is 0, 0 a solution?
No.
Very good. So which way do I shade it?
Up, like the other way up.
I shade it up. So that's where the intersection happens. Your intersection happens in that top quadrant where those 2 lines intersect. Okay. And if they asked you to find the solution or the point where they intersect, if you drew it right, you can kind of tell, and 3, 2 looks like where they intersect. But sometimes you don't draw it right, so don't just assume that it's correct. Plug in 3 and 2 and see, oh yeah, that works. 3 and 2, oh yeah, that works. So 3, 2 is where they intersect, or you could solve it with the other method, solving equations, right? Okay, you understand how that worked?
Yeah.
Okay, now again, this is the way I would suggest you do it if the lines are written in standard form like that. If the lines were written like this, if they were written like y is greater than or equal to 2x minus 3 and y is less than x plus 1, don't do it that way, right? If it was written like this, start with your y-intercept and then use your slope to find your next point. And then use this just to shade your graph up because you know it's y is greater than, so you shade it up.
Oh, okay.
So this is a difference, right? And honestly, some teachers teach you just to solve this for y, to put this in slope intercept form. But what I've found is that a lot of people make mistakes when they do that.
Mhm.
And it's better to just leave it as it is, in my opinion, and find your two intercepts. Because
Okay.
really your two intercepts are the two most important points if you can see them on a graph. Right? If you're doing the line, you might as well find what the intercepts are. That's my opinion. Now, sometimes there's not two intercepts. Sometimes there's only one because it goes through the origin, which is the X and Y intercept. In that case, you have to just find another point besides that one. Okay?
Okay.
Good?
Mhm.
Number 34 says write a polynomial function with a value of 1 in standard form with an a value of 1. Okay, sorry. With an a value. That standard form is this. Y equals ax squared plus bx plus c. They're telling you to make this 1. That's what they're saying right here.
Oh, my bad. I sent the wrong picture. It said factored form. I didn't know that he changed it until I looked at the other sheet and he said to make it factored form.
Okay, well, either way, we're going to start with factored form.
Mhm.
I'll do both. We're going to start with factored form. So here's what factored form is. You can see every time you have a zero, you know that that zero, each one of these zeros is related to a factor. So if my zero is -4, then my factor, solve that equation for 0 or set that equal to 0 and you'll have your factor. What's my factor here? If I move the -4 over to the other side, what do I have?
X minus equals
X, not minus.
plus 4 equals 0.
X plus 4 equals 0. There's your factor.
Mm-hmm.
You understand? That's your factor.
Yeah.
So X equals -4 means I have two factors of X plus 4. And X equals -1 means I have what?
X plus 4 equals X plus 1.
X. X plus 1. So my equation, my polynomial function is going to be y equals, if I leave it in factored form, I just write it like this. X plus 4 times X plus 4 times X plus 1. And if I wanted to write it even more efficiently, it would be y equals X plus 4 squared. Got it?
Mm-hmm.
Times X plus 1. So that's factored form. Got it?
Mm-hmm.
That's factored form. If they want it in standard form, then you just need to multiply it out. So to put it in standard form, you multiply it out. So X plus 4 times X plus 4 times X plus 1. This would be X squared plus 8X plus 16.
Mm-hmm.
And then this is X plus 1. And then you multiply the X in. So X cubed plus 8X squared plus 16X. Then you multiply the 1 in plus X squared plus 8X plus 16. See how I did that?
Mm-hmm.
I know I did it fast, but. And then you simplify it. So that's just X cubed. Let's see, we have 9 plus 9X squared, or squared, plus 9X squared plus 24X plus 16. So this is standard form. And this one's factored form up there. Okay?
Okay.
So there's both of them. So how about letter B? What would the factored form be? Let's go straight to factored form. You can do this without showing much work. What's the 0 if X equals 0 is one of your zeros? What's the 0? This is the one most people forget. It's just X.
Yeah.
Good. It's just X. And how about if 4 is? What's the factor?
X minus 4.
Good. And how about 3?
X minus 3.
And how about -3?
X plus 3.
There you go. And there's your answer.
Okay.
If you want factored form. Now, if they want this to be so this is factored form.
Mm-hmm.
And if you want it to be in standard form, like I said, just multiply out, but be smart about it. Multiply these out first, X minus 3 and X plus 3, because that just gives you X squared minus 9. and then multiply the x in, so that's x squared minus 4x, and then just FOIL this out. So that's x to the 4, that's minus 9x squared, that's minus 4x cubed, and that's plus 36x. So in standard form, we just put it in order. So it's x to the 4th minus 4x cubed minus 9x squared plus 36x. And there's standard form. Okay?
Yep.
All right, let's see. Sketch the graph of the following. All right, so here's the deal with end behavior and all this kind of stuff. I'm going to zoom in on this, and then we'll make a duplicate of this, and we'll do the next one on the next page. So here's the deal with multiplicity. First of all, you want to factor it, okay? So we're going to factor this. Uh-oh. Didn't mean to do that. Somehow it went away. Okay, we're going to factor this first. So let's factor an x squared out. Do you see how that factors out?
Yeah.
And you'd have an x squared left minus an x minus a 6, right? And how does this factor now?
X. Oh shoot. X squared, x minus.
So what multiplies to -6 and adds to -1?
Oh, -1 adds to
what two things multiply to -6? It's either 6 and -1 or 3 and 2.
-3. Wait, negative.
Yep, -3 and +2. Good.
Positive, yeah.
Because these now are going to add. This is going to be -3x, and this is going to be +2x, which adds to -1x. Got it? So that's how you factor. Okay. So what do I have? Well, I have a 0 of 0, right? So my zeros are going to be 0, right? X equals 0. And that's got multiplicity too. Can you see that?
Yeah.
Because of the squared here. Okay. Which means it's going to go through. I'm sorry, bounce. Which means it's going to bounce. That's what multiplicity means. Okay. And then I've got zeros of 3 and -1, -2, right? See how I did that? And those both have multiplicity what?
1.
Right, which is odd, which means they go through, right?
Yep.
So we're going to draw our points in here. My point is, here's one at 0, here's one at 3, and here's one at -2. And now we're going to look at the end behavior. Do you understand end behavior?
Yeah, so for the question, for the multiplicity, if it's odd, does it always go through?
Yeah, if it's odd, then it goes through. Yep.
Okay.
So here's how end behavior works. The easiest way I find to do end behavior is 2 steps. Step 1 is you look at the leading coefficient, right? If the leading coefficient is positive, then what does that tell you?
It goes up.
It tells you that the right end, that's right, the right end behavior is up. And if the leading coefficient is negative, that tells you that the right end behavior is what?
Left. Down.
Is down. Good. Is this how your teacher taught it?
Not really.
This just makes it so much easier. You just have 2 steps.
He just had a lot more wording to it.
Yeah. It's just 2 steps. Look at your leading coefficient. That's the first step. If it's positive, then the right end behavior is up. If it's negative, the right end behavior is down. Step 2, look at your degree. If the degree of your polynomial is even, then the left end behavior is the same.
Mhm.
I need some more space here. Step 2, look at your degree. If the degree is even, then that means that the left end behavior is the same
Mhm.
as your right end behavior. If the degree is odd, then that means your left end behavior is opposite of your right end behavior.
Mhm.
Okay, so
Yeah.
let's do this one step at a time. What's the leading coefficient? What is the leading coefficient? You see how it's just 1?
Oh, yeah.
It's just 1, so it's positive,
Mhm.
right? So what's that mean about my right end behavior?
It'll go up.
It's going up. So this is going to go up. So I'm just going to put an arrow up there on the right. And then what's the second step? What's the degree?
The degrees even.
It's even. So what does that tell you about your left end behavior?
It'll be the same. It'll go up.
It's the same, which means it goes up. Got it? So the
Mhm.
left end behavior goes up as well. So it's up on the left and it's up on the right. Now let's just go through or bounce. How about for this one? Do I go through or bounce?
Through.
I go through, so go through. How about the next one?
Bounce.
Bounce, so do a bounce here. And the last one better be through, right?
Yeah.
Because it's going up, and sure enough, it is through.
Mhm.
So there you go. There's your graph.
Oh,
And it also said find the Y-intercept. So the Y-intercept you can tell is just 0, right?
yeah.
The Y-intercept, like I said, it's always good to have your X and your Y-intercept, but that we
Mhm.
already had that one. Okay, let's try this one. Let's do that same thing with part B.
Mhm.
Okay, let's do the end behavior first. What's the leading coefficient?
A 1.
It's 1. So that's what?
Up.
It's positive, so it's going up on the right. And how about the degree?
It's 1.
Well, the degree is going to
Wait.
be this times this
Oh,
times this.
3.
See how many factors there are? Yeah.
Yeah. Yeah.
The degree is 3, which is odd, which means it does what?
Uh, the opposite, so it'll go down.
It's going to do opposite. Very good. So it's going down on the left.
Yeah.
I kind of drew that wrong. It's going to be like that. Okay, and what are my zeros?
1.
0,
0. Yeah. 2.
2,
-5.
and -5. We got it. Good. So let's plug them in. There's 0, there's 2, there's -5. It goes up on the right. And by the way, all of these do what? They're all odd, right?
Yeah.
They're all odd multiplicity. So they all go through, right? So it's going to go through, through, through.
Mhm.
And they don't want you to be too particular about how high and low it goes.
Yeah.
That's for a different class. Okay, pretty simple.
Mhm.
Awesome. Oh, that was it. Nope, that's not it. Okay, let's do 36. Write the equation of the polynomial in factored form. Well, let's just analyze just like what we did. You see we have a 0 here. What kind of 0 is it?
Wait, what?
Do you
Oh,
see the 0?
yeah.
It's at 1, right?
Yeah.
So that means I have x minus 1 is a factor, right?
Yeah.
But what does it do? Does it go through or does it bounce?
Bound.
So I have to make it squared, right?
Yeah.
And then how about this one over here?
Oh, that is -3.
So x
X plus 3.
plus 3, good. And what's the only other thing I have to do? You see how it's going down to the right?
Yeah.
So what should it be? What does that mean about my leading coefficient?
It is negative.
That's right. So I'm going to say y equals negative x
Yeah.
minus 1 squared times x plus 3. Now, you can also look at your y-intercept.
Mhm.
And your y-intercept, you might have to add something else besides just the -1. The y-intercept is -1. So let's plug in 0 and make sure that works.
Mhm.
0, 0. If I plug in 0, what am I going to get? I'm going to get -1 squared times 3, which is what? And I'm going to have a negative in front of it, right?
Oh,
So
3.
that is -3. I don't want it to be -3. I want it to be -1. So I have to adjust this. Instead of making it just a -1 in front, I'm going to make it a -1/3, because what's that going to do to it? If I make that a -1/3, that 3 and that 3 are going to cancel, and I'm going to get -1.
Yeah.
That's how you do that.
Oh, okay.
Okay.
Yeah.
Now you could plug in. Here's another way you could do that. Let me show you the official algebraic way of doing it. You can actually just plug in, or you can put an A here. You can put an A in front of there, and then you can plug in 0. Plug in your point that you have, your y-intercept. Plug in 0. Plug in 0 for x. This is the more formal way of doing what I just did. And plug in -1 for y, because that's your y-intercept, right? See how I get -1 when I plug, whoops, should have put 0 in here. When I plug 0 in for x, I should get -1, right?
Yeah.
And now just solve this equation for a. So -1 equals a times -1 squared times 3.
Mhm.
So a just equals -1/3,
Mm. Okay.
which is essentially the same thing that I did before. I just didn't use the a.
Okay.
Okay.
Yeah.
All right, let's do 37 while we're here. So to find real and imaginary solutions, well, factor if possible. They even told you begin by factoring. Well, first I have to set it all equal to 0.
Mhm.
So I'm going to have to move these over, or move the 10 over by adding it. And now whenever you have a 4-term polynomial, quadnomial, I would try factoring by grouping, because in this class, chances are it's going to work out that way,
Mhm.
because they make them nice. They make them nice and convenient, easy. See how I can factor an x squared out of here, and I'll get an x plus 2. And if I factor a 5 out of here, I'll get an x plus 2. You see that?
Yeah.
So now I have an x plus 2 and an x plus 2. That's a factor of this term and a factor of this term. So I can factor it out or undistribute it. I'm going to pull an x plus 2 out, and I'm going to have an x squared left here and a 5 left here. Okay.
Wait,
Now I'm not done. Did you follow what I did there? Did I go too fast?
Can you say it one more time?
Sure. This is just factoring by grouping.
Yeah.
I grouped the first 2 terms, and I factored an x squared out,
Mhm.
and I had an x plus 2 left in here, x plus 2. I take an
Mhm.
x squared out. I took a 5, and then I grouped the last 2 terms. I took a 5 out. If I take a 5 out of here, I have an x left. If I take a 5 out of here, I have a 2 left. So
Mhm.
now I have an x plus 2 and an x. See how I've got the same factor here and here?
Yeah.
So I'm factoring that out. I'm factoring that out of both of those. It's another common, or it's a common factor, GCD.
Mhm.
I'm taking that out. Pretend like this is like y.
Mhm.
If this said x squared times y plus 5 times y, you would take the y out, right?
Mhm.
That's all I did.
Okay.
And now I'm going to use the zero product property. I'm going to set each one of these things equal to 0. So x plus 2 equals 0,
Mhm.
and x squared plus 5 equals 0. In this case, x equals -2. And in this case, x squared equals -5, which means x equals what? Plus or minus I root 5.
Oh, so okay, that's how you do imaginary.
Yeah, because if you do, let me show you the little thought bubble over here.
Mhm.
If I'm trying to solve this equation, x squared equals -5, I want to take the square root of -5,
Mhm.
but I can't do that in the real number system. But the
Okay.
square root of -1 is I. So I
Oh.
rewrite this as plus or minus I, put the I in front, root 5. So I took that
Okay.
I took that negative out and made it an I.
Mhm.
Okay.
Mhm.
All right. Part B is a little trickier. So first step, like before, set it equal to 0. You
Mhm.
got to set it equal to 0 because that's how you use the zero product property.
Mhm.
0 is a very special number because of the zero product property. So if I can somehow turn this into 2 factors or more than 2 factors that equal 0, I know that each of those factors has to be equal to 0, like this right here. See, I got this factor times this equals 0. Well, that only can happen if and only if this is 0 or this is 0. So
Mhm.
that's why I set it equal to 0. Okay, just to be clear. So can you see how this kind of looks like doesn't this kind of look like a quadratic a little bit?
Yeah.
See how there's 3 terms?
Yeah.
And in fact, it kind of is a quadratic. If I think of this as x squared squared, and this is just x squared. In other words, if I think of, I don't know, I'm going to let it u, I'm going to rename u as x squared. Okay.
Mhm.
And then I'm going to write this equation. This equation would not be, instead of calling it x to the 4th, can't I call it u squared? You see what I'm saying?
Sure. Yeah. Oh,
And
yeah.
and couldn't I call this plus 5u? Couldn't I just call that u?
Yeah.
Minus 6 equals 0. And the only reason I do that, the only reason I substitute that is because it's easier to see for people.
Mhm.
Now, can you solve for u? Can you solve this equation for u? Isn't that a lot easier? Can I factor u? How does that factor?
Mhm.
U and u, positive 6 and -1. Does that work?
Where's the -1 coming from? Oh, to make
Because,
a -6. Oh, yeah. Okay, never mind.
got it?
Yeah.
So what would that mean? That would mean that u would equal -6 or u would equal 1, right?
Mhm.
Well, that's awesome. Except I don't want to solve for u. I want to solve for
X.
x. So instead of, now I'm going to take what I said u is equal to, and I'm going to plug that in. So u is really x squared, right?
Yeah.
X squared equals -6 or x squared equals 1. Now let's solve these.
Mhm.
This means x equals, just like I did before, plus or minus I root 6.
Mhm.
Got it?
Mhm.
And this means x equals plus or minus, don't forget the plus or minus 1. So
Okay.
there are my 4 answers. I have 4 answers because that was a 4th degree polynomial.
Oh, all right.
Okay, good.
Yep.
And that was it.
Mhm.
Boy, we got through a lot. Questions about any of that stuff? You feel pretty good about it?
Yeah.
All right. So what I would recommend that you do is go back into, so on my YouTube channel, you'll be able to see, I'll show you how to do this real quick. I'll go to it. This will be as soon as I finish here, as soon as I close it, which